Hello everyone, myself Shaheed-ul Islam, physics faculty, screening to present the video lecture session from YouTube channel platform powered by Platform Institute. Dear student, the platform a premier institute started in journey since 2015 for the student appearing medical, engineering and board examinations. Platform never compromise with quality of teaching and every endeavor is directed towards directly benefiting students. Platform feels the urge and necessity to launch this channel on demand of students. We will be covering digital video solution of physics from platform major test questions. Students are suggested to collect the questions from platform office or download from official website www.platformedu.org. Video solution of 7 major tests and 10 mock tests will be published through this channel. Practice is the key to success. Crack NEET and JEE with most comprehensive online live video lecture in which we will solve numerous tricky questions, some even without touching pen and paper, that is penless method. Study from your comfort zone, become a top ranker by preparing with our foolproof strategies. Stay tuned with us, do subscribe to the channel, share the link to your friends and help us to reach every corner. Free education for all must reach to all aspiring students. Let us begin our first questions. Everyone have a look over here. If an electron and proton have same de Broglie wavelength, so de Broglie wavelength lambda equal to, we know, h by p, here p is momentum and h equal to Planck's constant. Since in this problem wavelength of electron is equal to wavelength of proton, so we can write here h by momentum of electron by h by momentum of proton. Therefore momentum of electron is equal to momentum of proton. Very simple question, straightforward questions. So right option here, both have the equal momentum. If the distance covered is 0, then displacement, we know magnitude of displacement, it is always less than equal to distance. So therefore you can say if the distance covered is 0, then certainly the displacement must be 0. Next problem. A object is thrown horizontally from a point A from a tower and 3 seconds later at B. So height of this tower h is equal to half gt square equal to half into 10 into 3 whole square, that is 45 meter. And we can say, you know, BC by h equal to cot 30. So therefore BC, that is horizontal displacement of the particle, equal to h cot 30 and it is 45 √3 meter. Since this body is projected from the top of the tower with some horizontal velocity, so the horizontal velocity of the body remain unchanged at any point of this path. Horizontal velocity does not change and body starts moving downward or vertically displaced because of the gravitational acceleration, but angle between G and V, it is always perpendicular, so the magnitude of the horizontal velocity remains unchanged all along the path. Horizontal displacement x is equal to v into t, and you know v into 3 second time taken to fall down on the ground equal to 45 root 3, and from here we can say 15 root 3 meter per second. So correct option matches here is 1. Next problem. A ship is traveling due east at 10 km per hour. As per the geographical convention, it is north, south, east, west. A ship is moving towards east. Let us say the velocity is u. Another ship moving with velocity v at an angle 30 degree, that is angle east of north towards east, angle with north, so 30 degree with the north, and always due north. A ship heading north is always due north from the first ship. So with respect to the ship 1, and this is ship 2, we can say, so with respect to this ship, the relative velocity of ship 2, it is omega and directed towards north. So the two velocities of the ships 1 and 2 must be taken by the adjacent sides of triangle in reverse order. Third side, arrowhead given towards 2 represents the relative velocity of 2 with respect to 1. From triangle law, we can say, we know u vector plus omega vector equal to v, and omega equal to v minus u. So problem is very simple. If we draw the triangle, simple triangle, by taking the two velocities by adjacent sides of a triangle in reverse order, and third sides towards arrowhead towards 2 represents the relative velocity, and from this it is 30 degree, and we have to find out v by u equal to cosec 30, and v is equal to, this is u cosec 30 and cosec 30, and the velocity u given there 10 into 2, that is 20 km per hour. The speed of the second ship, and correct option here 3. Next problem. A ball is thrown at some angle with horizontal, returns ground describing a parabolic path, you know. In a projectile, one particle is projected at an angle, let us say theta. So horizontal component, we can get horizontal component u cos theta, and this is u sin theta, u cos theta remains unchanged all along the path, because you know G is perpendicular to u cos theta component, that is horizontal component. So at any point of the projectile, the velocity of the horizontal velocity of the particle u cos theta and u cos theta, so horizontal component always remain unchanged. Right option here. 4. A potential difference of 20,000 volts is applied across X-ray tube. The cutoff wavelength will be, you know, in Cooley's tube it is target metal, as an anode. It is anode and cathode. Electron moves in the direction from negative plate to positive plate. Thermonic electron thermonic electrons from the anode, from the cathode, get some kinetic energy, and with some kinetic energy it is suddenly stopped by the high melting point metal. If we consider if kinetic energy of electron converts by 100% into electromagnetic energy, then we can say energy of X-ray H nu equal to half mv square. So the total kinetic energy or mechanical energy converts into electromagnetic energy of X-ray. It is possible when any moving charge suddenly stopped or accelerated. We know accelerated and deaccelerated charge always produce electromagnetic waves. So if this electron of high kinetic energy suddenly stopped by the metal, so total kinetic energy in ideal condition, if we say that converts into the electromagnetic energy, then we can say H nu equal to half mv square. And this energy comes from the potential difference given in the Cooley's tube. And frequency here is maximum, and H, this can be written the equation Hc by lambda equal to EV. We know minimum wavelength corresponds to maximum frequency. So from this equation, lambda minimum equal to, we can say, AC by EV. and this is 1240 by V in volt. If we put the values of Planck constant and the speed of light and the electronic charge, we get the 1240 by V in volt, and it is nanometer. So this is very important formula. Minimum wavelength of X-ray, and this wavelength is also called cutoff wavelength. Cutoff wavelength. So by applying this formula, we can find the answer. Lambda equal to 12,040 into 10 to the power minus 9 by 20,000 volt. And by simple calculation, we can say the result is 6.21 10 to the power minus 11 meters. So right option matches with 2. Move on the next problem of this session. A diatomic ideal gas is heated at constant volume until the pressure is double. You know, V fixed, it means the process is iso C and P versus T, and the amount of heat given in this process at constant V equal to, we can write here NCV del T. Since the pressure is double, the temperature of the gas is also becomes double. So NCV, it is 2T minus T. Similarly, in the second process, P fixed, it is iso B. I mean, iso B stands for isobaric process. Here we can say V versus T. So in this process, the amount of heat supplied to the gas at constant pressure is NCP del T. You know, temperature finally at the process iso C is 2T, and again the volume becomes double. So obviously by linear relation, we can say if this volume is double, temperature also becomes double. So NCP, it is 40 minus 2T. Initially the temperature is 2T. So total heat in this process, given it is del Q at constant V and del Q at constant pressure, and we can say that N F by 2 R T plus N1 plus F by 2 into R into 2T. This is the amount of heat given in the process. You know, N is the number of moles, I have written there, and F is the degree of freedom, and the gas is diatomic gas. Since this gas is diatomic gas, we can say the degree of freedom is 5 by 2 into RT, and number of moles is N, 1 plus 5 by 2 into R into 2T. So therefore N into 5 by 2 plus 7 into R into T. We can write by simple calculation N 19 by 2 RT. So total heat supplied in these two process First process is a isochoric process and second process is isobaric process. So total heat supply to the gas is del Q is equal to, we can write in 19 by 2 into RT, and specific heat, we have to find out the specific heat. Specific heat, as per the definitions, the amount of heat required to change unit temperature of per unit mole of gas. So N del T, okay, here the amount of heat given in 19 by 2 into RT, and temperature change, initially the temperature of the gas is T and finally the temperature of the gas is 40. So this is 40 minus T, and right option here 19 by 6 into R. Correct option matches with 2. Let us see the next question. PT diagram is shown below, then choose the corresponding V versus T graph. Here in the graph A to B, it is iso T. Iso T means temperature of the gas fixed. So according to Boyle's law, pressure goes on decreasing. Therefore, we can say the volume at point B is greater than the volume at point A. Okay. Or the process BC. This is the line BC passing through origin P versus T graph. So it is P versus T. P versus T means V fixed. So this process is iso C. The process is iso C. Okay. Similarly, C to D, it is also iso T, that is T fixed, and from the graph we can say VD greater than VC. Pressure goes on decreasing, so volume of the gas increases. Okay, so here BC is the isochoric process. BC is the isochoric process. So volume remain fixed. So option 2 is not the right option. This is not correct. And here the volume of the gas at point B is greater than the volume of the gas at point B is greater than the volume of the gas at point A. So this is also not the correct option, because here the volume of the gas is less than the volume of the gas at point A. Similarly, here the volume of the gas is greater than B. The volume of the gas at point B is greater than the point A, but at the volume of the gas at point D is greater than the volume of the point. Here the volume of the gas at point D is less than the volume of the gas at point C. But from this graph we can say the volume of the gas at point D is greater than the volume of the gas at point C. So 3 is also not the correct option. So 4 is the right option. Next problem. A perfect gas of given mass is heated first in a small vessel and then in large vessel such that their volumes remains unchanged. The P versus T graphs are. We know PV is equal to mu RT and P equal to, this is mu R by V into T. Here mu is the number of moles. I have taken mu is the number of moles. P equal to, we can say, M into T, and M is the slope of the graph. If we draw the graph between temperature and pressure, we can get a straight line passing through origin, and the slope of this graph tan theta equal to M. Okay, but this M is equal to, mu R by V. So therefore M varies as 1 by V. For small vessel, V small, then we can say M large, because the volume of the container is the volume of the gas. And for large vessel, V large, and slope of the graph is small. So parabolic with same curvature, this is not right option. Parabolic with different curvature, this is also not correct option. Linear waves with same slope, no. So the right option here, linear with different slopes. Next, find the amount of work done to increase the temperature of 1 mole of an ideal gas by 30 degree if it is expanding under the condition V versus T to the power 2/3. Before solving this problem, I must say, if in polytropic process, let us discuss what is polytropic process. If we write PV to the power x equal to constant, then the corresponding V versus T graph will be, by simple deduction, though it is not necessary to reduce this equation, just you have to keep this equation in your practice through practice session, and P to the power 1 minus x, T to the power x equal to constant. So corresponding pressure versus time graph, and specific heat in this process, C is equal to, we can say, CV plus R1 minus X. This is very important formula you have to use in your examination hall. You should keep in mind CV actually corresponds to change in internal energy, and the part R by 1 minus X, it is corresponds to work done. Okay, so this is very important for any polytropic process. Specific heat all time, C equal to CV plus R by 1 minus X. And if we solve this problem, very simple problem, this becomes very simple. In the problem given, V varies as T to the power 2/3 and it is rearranged, we can say T V to the power minus 3 by 2 equal to constant. Okay, and comparing with the equation x minus 1 equal to minus 3 by 2. In this way, x is equal to minus half. And work done all time, you have to write nr1 minus x into del T. Number of moles given, it is 1 mole. So 1 into r 1 plus half into 30. Temperature change is 30 degrees centigrade. We can say R into 20s, and putting the value of R, we can get 20 into 8.3 joules. So the right option here is 1. Next, a Carnot engine takes in 3000 cal of heat from reservoir. We know efficiency. Eta is equal to, it is work done by heat absorbed by engine from the source, equal to, we can write 1 minus Tc by Th. Tc is the temperature of cold reservoir, whereas Th is the temperature of hot reservoir. Work done and the heat taken from the source, 3000 cal, it is 3000, and temperature 27300 Kelvin by 900 Kelvin. Work done by 3000 by 2/3, and the result is work done is equal to 2000 cal. Though the cal is the unit of heat, but we can write also the amount of work done in terms of cal. So right option here is 1. Next problem, when x amount of heat is given to a gas at constant pressure, it performs x by 3 amount of work. We know gamma equal to gas amount of heat supplied to the gas or by change in internal energy. So amount of heat by change of internal energy is the gas exponent. From the definitions we can say, don't say gamma is equal to Cp by Cv. Cp by Cv is the value of gamma, but by the definitions we have to write amount of heat supplied or to the change in ratio of amount of heat supplied and change in internal energy. You know the amount of heat given in this process is x, and from first law, amount of heat is equal to del Q equal to del U plus del W. So del U equal to, we can say x minus x by 3, and this is 2x by 3. We can write here 2x by 3. So this becomes 3 by 2. So gamma exponent of this gas, as per the given in the questions, you know, it is 3 by 2, and 1 plus 2 by f equal to gamma, where f equal to, you know, degree of freedom. One plus 2 by f, and this is 3 by 2. Therefore we can write 2 by f is equal to half, and degree of freedom equal to 4. Right option is 2. Velocity of liquid coming out of a small hole of large vessel containing two different liquids of density 2 rho and rho as shown in figure. In this figure, two types of liquid is used. Here the liquid used is 2 rho and there is a hole in this. Here you can get a hole. And the other liquid, it is given density rho. Height of this liquid is 2h and height of the liquid of density 2 rho is h, and liquid coming out from the orifice, it is the density 2 rho. So we have to convert the liquid rho into the density of liquid 2 rho. Simply, you don't apply the Bernoulli's theorem in this problem. If we apply Bernoulli's theorem in this problem, then it will take more time for getting the answer for such type of problem. My suggestions, you just take the pressure at the point. If we find the pressure of the point at the point of hole, at the point of orifice through which the liquid coming out of the container, height of the liquid is h and density of the liquid is 2 rho. This is G because of the liquid of density 2 rho, and similarly pressure because of the liquid of density rho, height is given here 2h and density rho into G. Here 2h rho G and here 2h rho G. So total liquid, better to take, you just convert the liquid. This is height h and density is 2 rho into G, and converts this liquid of density rho into the density of 2 rho. So we can say the height of the liquid h and density of the liquid becomes 2 rho, but the height becomes h, though it is given 2h, but this time when if we consider the density of the liquid is 2 rho, then the height is half, that is h. So total height of the density of liquid 2 rho into G. So we can say the height of the liquid column of density is 2h, height of the liquid column is 2h of density 2 rho, having density 2 rho, and velocity of efflux is equal to, we know that 2gy, y is the depth of the orifice, y is the depth of the orifice. So putting this, we can get the result simply. Y is equal to 2h, so result is equal to 2 root over gh. Right option here is 2. Next problem. If the frequency of light in a photoelectric experiment is double, the stopping potential will be. Let half mv square is the maximum kinetic energy, it is h nu minus work function, and in the tube electron of maximum kinetic energy can be stopped by applying negative potential to the anode with respect to cathode. And this kinetic energy by the negative potential Vs, kinetic energy of the electron becomes 0. So simply we can say EVs equal to half mv square, that is maximum kinetic energy of electron. This equation EVs equal to h nu minus work function. Here nu is the frequency. If frequency, new frequency, if it is n times greater the frequency of incident light previously, then the new stopping potential EVs equal to, we can write NH nu minus work function. Okay, and you know h nu equal to, it is n EVs plus work function minus work function. So the new stopping potential for the frequency of n times the greater than the previous, we can say it is NVS n minus 1 work function by E. It is very instrumental formula or advanced formula you can apply in the MCQ type questions. Don't do this job what I have done here. You just keep this formula, new stopping potential equal to NVS n minus 1 work function by E. This is new potential, new stopping potential. If we put the value n, it is double. That is, if we put the value of n is 2, then we can certainly say the new stopping potential will be more than the double. Next problem. A spherical drop of water has 1 mm radius. If the surface tension of water is 50 meter 10 to the power minus 3 Newton meter, you know this is spherical drop, and outside it is P naught as atmospheric pressure in all direction, and you get here the pressure P naught plus P. P here is the excess pressure. It is known as excess pressure. Due to surface tension 2S by R. Here S is the surface tension and R is the radius of the spherical drop. So simple questions, the pressure difference between inside and outside of the spherical drop, it is obviously it is P. That is the excess pressure due to the surface tension. Solution of this problem, we can do this job very easily. P equal to, we can write 2 into S given in the problem is equal to 50 into 10 to the power minus 3, and the radius is 1 into 10 to the power minus 3 meters. So right option here, right answer here is 100 Newton per meter square. So option matches with 3. Let us move next question. A stream of water flowing out, a stream of water flowing from a tap becomes narrower as it falls. This can be explained by water is oozing out of a tap. If we take here the velocity is v1 and the cross section is a1, and another point if we take the velocity is v2 and the cross section a2. So from equation of continuity, we know AV equal to constant, that is the volume of liquid flowing out per second. Here A is the cross-sectional area, V is velocity of fluid flow. So from equation of continuity, A1 V1, we can say it is A2 V2, and the ratio of A2 by A1 equal to V1 by V2, and it is less than 1. Since you know the water is falling down under gravity, so velocity is greater than V1. Simple. So conservation of, it is known as conservation of volume flux. Volume of liquid flowing through this orifice and volume of liquid flowing through this orifice per second are equal. This is known as volume flux, conservation of volume flux. Okay, the next problem, a vertical column 50 centimeter long at 50 degrees centigrade balances another column of same liquid 60 centimeter long at 100 degrees centigrade. We have to find out the coefficient of expansion of the liquid. If we consider a U-tube, it is not U-tube channel here. This is the container of liquid having two arms, and in one side the height of liquid is 50 centimeter, and another side the height of liquid, it is given 60 centimeter. I have drawn this figure for your better understanding. If we take 2 point at, if we consider 2 point A and another point at the same horizontal line B, so from the equilibrium we can say pressure at point A and pressure at point B equal. Okay, so H1 rho 1 G equal to H2 rho 2 G, because both the arms having the different density at different temperature, and rho 1 by rho 2, it is H2 by H1. But we know density variation with temperature, it is the density at 0 degree centigrade, it is 1 plus alpha, 1 plus gamma T. That means with the rise of temperature, the density of the liquid decreases. We can write in this equation rho naught by 1 plus gamma T1 by rho by 1 plus gamma T2 equal to H2 by H1. And finally 1 plus gamma T2 by 1 plus gamma T1 equal to H2 by H1. Now we have to put the values. 1 plus gamma, it is 1 plus 100 gamma, temperature in one side 100 degrees centigrade, and temperature at other side is 1 plus 50 gamma, and height in this side is 60 by 50. So by simple calculation, 200 gamma equal to 1, or gamma equal to 1 by 200 per degree centigrade. Right option is 1. Next problem, for which combination of temperature the efficiency of Carnot engine is highest. We know efficiency, already we discussed in previous questions, it is Tc by Th. This eta increases when ratio Tc by Th decreases. So very important that what is the ratio of the temperature of the cold reservoir by hot reservoir, that is sink temperature by source temperature. By error and trial method, the ratio, you know, 6 by 8 means 3 by 4, and the ratio here is equal to 4 by 5, and the ratio here is equal to 2 by 3, and ratio for 40 and 20, this for this pair is half. So this is the half is the least value for this combination. When the pair is least, the ratio of the pair is least, efficiency of the engine is highest. So therefore the right option here is 4. Next question, when temperature of a rod increases from T to T plus del T, the moment of inertia increases from I to I plus del I. So very simple questions. Moment of inertia I equal to m k square, and k is the radius of gyration. On hitting the new radius of gyration, we can say 1 plus alpha t. Here t I have taken temperature change, and alpha is the coefficient of linear expansion. Okay, and from this we can say del k by k, that is relative change in radius of gyration, is equal to plus alpha t. Here plus represents with the rise of temperature, the radius of gyration goes on increasing. And we know del I by I, relative change in moment of inertia, we can write it is 2 del k by k, and very simple, it is 2 alpha t, and answer is 2 alpha t. T here is the change in temperature. Correct option matches with 4. Let us move next problem. The de Broglie wavelength of an electron in nth orbit of radius Rn, according to de Broglie periphery of orbit around nucleus of an atom twice pi r n equal to n into lambda. Here n is the quantum number, n is the quantum number, and lambda is de Broglie wavelength associated with orbiting electron around nucleus. Okay, and from Bohr atomic structure, radius of any orbit is equal to n square a naught. A naught is the radius being given of first Bohr orbit. So putting here twice pi n square a naught equal to, we can write n lambda. N is the number of waves of de Broglie wave associated with the moving particle, associated with orbiting electron around the nucleus. So wavelength associated twice pi n a naught, and answer is A. Next problem, if the kinetic energy of free electron doubles, de Broglie wavelength changes by a factor. Simple questions, you know, de Broglie wavelength h by p momentum, and this is h root over 2m k. K stands for kinetic energy. Kinetic energy of moving particle. Simple. Lambda varies as root over 1 by k. Since the kinetic energy is doubles, so wavelength decreases by 1 by root 2 times. Simple questions. Let us move. Next question. A particle of mass m at rest decays into two particles of masses m1 and m2. You know, it is explosion into two particle. Explosion into two particle. One particle explodes into two parts having mass m1 and velocity v1, and another part mass m2 having velocity v2. This is center of mass. Center of mass remains stationary since there is no external force applied for this explosion. Explosion takes place because of the internal force or internal energy. Since there is no external force applied, we can say the momentum conserved. So this is very fundamental idea, you know. Before explosion, if we take the momentum is Pb, and after explosion the momentum is Pa. So from conservation, it can be written from conservation of momentum. This is actually painless problem, but you should have this idea, fundamental idea. And momentum before zero and after explosion, the vector sum of momentum is equal to P1 plus P2. It is the vector sum of the momentum after explosion. Okay. And from this we can write P1 vector is equal to minus P2 vector. It is actually known as opposite vector. Opposite vector means magnitude of momentum of one particle is equal to magnitude of momentum of second particle, and direction must be opposite, direction opposite. So interestingly, when any particle explodes into two particles, you all time just keep in mind that their momentum, the magnitude of their momentum are equal. And de Broglie wavelength associated with moving particle is lambda, and P here is momentum. So simple, since the both particle having the equal momentum, so the de Broglie wavelength ratio of the de Broglie wavelength, obviously it is 3. Two cylinder A and B fitted with piston contains equal amount of ideal diatomic gas 300 K. The piston is free to move. Is free to move. What does it mean? Free to move means if we supply the heat, to the container, if the temperature of the gas increases, the pressure of the gas goes on increases, and because of the unbalanced pressure outside inside, the pressure of the gas becomes larger than the outside pressure and the piston moves up. And finally, pistons stops moving when outside and inside pressure becomes equal. So in equal, finally the pressure of the gas becomes the pressure initially. So we can say P fixed. In this case, if the A is free to move, we can say P is fixed. P is fixed, so this is iso B. And in this process, amount of heat supplied equal to NCP del T at constant pressure. Whereas in another cylinder, piston B fixed. If we increase the temperature of the gas, B fixed, it means volume of the gas remains fixed. No chance to increase the volume. So pressure increase. Because of the rise of temperature, pressure of the gas increases. And you know that heat given in this process, it is NCV del T at constant volume. But in the problem, one important information given. Heat supplied in both the process are equal. If the heat supplied in the both the process are equal, then we can say it is NCP del T bar del T P and this is NCV del T V. We know questions is temperature of the gas in B. So temperature of the gas, temperature change of the gas in cylinder B, that is as constant V, constant volume. Del V equal to, we can say del V equal to Cp by Cv into del T, the temperature change in constant pressure. Since this gas is diatomic gas, it is value of Cp by Cv equal to 7 by 5 and temperature change given in the problem is 30 K. This is 30 K and finally the answer is 42 K. Right option matches 4. Next problem. Amount of heat energy required to raise the temperature of 1 gram helium at NTP from T1 to T2. You know, from kinetic theory of gas, equipartition law of energy, internal energy of an ideal gas it is N number of moles degree of freedom by 2 into RT. This is the energy of an ideal gas, neglecting the potential energy of the due to intermolecular attraction of the molecules. Okay, as per the assumption of ideal gas. If we want to change the internal energy, then we can say NF by 2R into del T. Number of moles of helium gas 1 gram, molecular weight is 4. Actually mass of gas by molecular weight is the number of moles of the gas and it is 1 upon 4. Since this gas is monatomic gas, we can say 3 by 2 R is equal to Avogadro number into Kb and temperature change is given T2 minus T1 in the problem. So right option here is 3. Next problem. A gas mixture contains 8 molecules of oxygens and 2 moles of argon, that is mixture gas of diatomic and monatomic gas. We know again internal energy, it is N1 degree of freedom F1 by 2 into RT. Temperature of the mixture is T. Similarly, N2 F2 by 2 into RT. A gas of oxygen, that is 8 mole, degree of freedom 5 by 2 into RT, and here 2 moles, degree of freedom 3 by 2 into RT, and this is 23 RT. Correct option 2. Let us see what is next problem. A container contains 1.1 mole of hydrogen and 0.1 mole of oxygen. Thermal equilibrium. Thermal equilibrium means temperature of both gases are equal, and you know internal energy N F by 2 into RT. This is actually kinetic energy of gas molecules. Kinetic energy of gas molecules. Kinetic energy of the gas molecules is the manifestation of the temperature. So the kinetic energy of the gas molecules exclusively depends only the temperature. So we can't say only the average kinetic energy. Though it is the correct statement given, but we have to check all the options given here. Average speed of the molecules of hydrogen and oxygen. Average speed also, if we take the RMS speed, C is equal to root over 3 RT by M, and average speed root over 8 RT by pi M. So average speed also, or RMS or average, whatever may be the, also directly is directly proportional to the square root of the temperature, absolute temperature of the gas, since both having the diatomic gas, or one is molecular weight, or oxygen is greater than the molecular weight hydrogen, so their average speed are different, though their temperature are equal. Okay, average or RMS, whatever may be the, only the specific heat at constant pressure of the two gases is same. My objection is only, okay, here the specific heat and the kinetic energy are same for both gases. Right option is 4. As per specific heat, the definitions of specific heat is equal to amount of heat required to change unit temperature of unit mole gas. Both are the diatomic gas, so specific heat for both the gas are equal, so right option here is 4. Next problem. The root mean square speed of a hydrogen molecule is V1. RMS given in the problem, V1 is equal to 3 RT by, it is hydrogen, so we can write here 2, and the most probable speed, most probable velocity given for V2, it is also root over 2 RT by 32. And simple straightforward questions. If we find the ratio of V1 by V2, then it is 3 by 2 into 32 by 2. So this is 24 and it is 2 root 6. It is the ratio of the velocity V1 by V2. Correct option is 1. Next, a cylinder containing an ideal gas is in vertical positions and has a piston of mass m that is able to move up and down without friction. The temperature is increased. If the temperature of this gas is increased, so pressure of the gas also goes on increasing, and because of the unbalanced pressure outside, pressure let us say P atmospheric and pressure here is P, it will exert a upward force on the movable piston which can move without friction. There is no energy loss due to the friction. So because of this unbalanced pressure, the piston goes on moving, moving up and finally stops when pressure inside and pressure outside balances each other. So finally the pressure of the gas becomes equal to the pressure initially of the gas. But V that is volume of the gas increases if we rise the temperature of the gas. So right option here directly you can say it is 3. General breakdown take place. General breakdown takes place in heavily doped diodes when an electric field high enough is applied across diode charges move towards junction at a certain particular voltage avalanche breakdown is taken place. So right option always doped impurity is high. Next problem. In a common emitter amplifier having voltage gain we know AV equal to beta load resistance by input resistance, where beta is the current amplification factor, and transconductance GM, it is beta by input resistance. So comparing these two, voltage gain G equal to can be written is equal to GM into load resistance. Important formula, where GM is the transconductance. And from this problem, the transistor used transconductance 0.03. So here new voltage gain G prime by G, we can say GM prime by GM. And from the problem, it is 0.02 by 0.03. So new voltage gain becomes 3 into G. Current gain is not important here, it is just given in the problem, but we have to solve this problem by taking the transconductance, because voltage gain is equal to transconductance into load resistance. In both the cases, the load resistance is same, so therefore G proportional to GM, and in this way G prime 2/3 G, and right option is 1. Next problem, identify the correct statement related to cyclic process. In cyclic process, PV diagram, one gas undergoes the changes by cyclic process through A, B, C, D path, and another cyclic process in PV diagram, just a minute, another cyclic process A, B, C, D. For clockwise, cyclic process, work done is always negative, that is on the gas. And similarly for anti-clockwise, process, work done is always greater than 0, that is work done by the gas. Initially, final state and initial state in any cyclic process coincides. It is actually coincides. So this is right statement. And internal energy change, it is NCV del T, it is NCV into 0 equal to 0, because you know final and initial state are same state. So temperature of the gas, final temperature of the gas is equal to the initial temperature of the gas. So no change in temperature, that is change in internal energy is 0. And from first law, we can say del Q is equal to del U plus del W. Since the internal energy change is 0, we can say the amount of heat supplied to the gas is equal to the work done by the gas, or the amount of heat extracted from the gas is equal to the work done on the gas. So these are the right option, you know, del Q is equal to del W, del U is equal to 0, but here you have to find out the incorrect statement. So this is 3, because for cyclic process it is less than 0, or for anticyclic process it is greater than 0. Next problem. Which if the flowing pair's physical quantity does not have the same dimensional formula? Work done. Simple question. Work done is equal to F into X. Here X is the displacement, and torque, you know, tau is equal to, it is also F into X, and X is the perpendicular distance between axis of rotation. So dimensionally work and torque are same physical dimensionally are same quantity, but physically torque and work has the different meaning, though it is dimensionally same. Angular momentum and Planck constant. Angular momentum, we know kinetic energy, rotational kinetic energy equal to half pi omega square. It is differentiating with both sides with respect to omega, then we can write it is I omega. I omega is equal to angular momentum. So angular momentum equal to, actually energy stands for joule and it is rad per second, so we can say it is joule second. And similarly Planck constant, you know, energy is equal to H nu, and H equal to E by frequency. Frequency means per second, so it is also joule second. Number 3, tension is a force, or better to say it is reactive force. It is reaction by the string on the body. It is reactive force. Reactive force. But surface tension. Surface tension. S is equal to, it is actually force per unit length. Force per unit length. Force per unit length. So tension and surface tension does not have the same dimensional formula. 3 is the right option. Another option is 4. I must say impulse and linear momentum. Impulse is the impulse means change in momentum. Impulse is change in momentum, and momentum simply is a momentum. So therefore impulse and linear momentum have the same dimensional formula. Okay, next problem. Monochromatic light of frequency F. Simple problem. Energy E equal to H nu. Kinetic energy from the Einstein's equation, it is H nu minus work function. It is given in the problem HF minus, it is HF naught. Simple, very simple questions. Directly just you have to write the equation of the kinetic energy, maximum kinetic energy of electron, and answer is 2. Next problem. In the Davidson-Germer experiment, electrons emitted from the electron guns can be increased. Only electric field can accelerate charged particle and can energize charged particle. Only electric field. Magnetic field does not provide energy to the charged particle. Can change the direction of velocity without changing its magnitude. Very basic fundamental concept you should keep in mind all time. Electric field can accelerate the charged particle or also can energize the charged particle. That is, kinetic energy of the charged particle can be increases or decreases by electric field. Whereas magnetic field never provides any energy to the charged particle, but it can change the direction of the velocity without changing its magnitude. Though the question is asked Davidson-Germer experiment, but the question is electron guns, velocity of electrons emitted from the electron gun can be increased. So increase the potential difference between anode and filament, that is potential difference of an electric field. So right option is 1. Next problem. Choose the correct statement. Photoelectric effect can take place from bound electron. Photoelectron actually absorbs the energy of incident ray on the metal surface, incident upon the metal surface, and the quasi-free electrons loosely bound with the nucleus, which can easily absorb the quanta energy of photon, and from the energy of photon, electron goes on a higher, electron gets down the higher state, and if the energy is sufficient, so it will come out of the surface of the metal surface, and these electrons is known as photoelectrons. Though the question is asked bound electron, there is no questions that the photoelectric effect can take place from the bound electrons. Bound electron means electron which is very near to the nucleus and rigidly bounded to the nucleus. So there is no question arise of the bound electron. Photoelectron can take place from the free electrons, though no electron is completely free, it is quasi-free. So since the question here, the statement given in this way, so I have to write here the answer is 2. Or we have to take the right option is 2 here, free electron, you can roughly say. Next problem. Graph between kinetic energy of ejected photoelectrons and the frequency nu of the incident radiation. Here along this direction kinetic energy, along y-axis, and along x-axis it is given frequency, and it is straight line. We know maximum kinetic energy of electron according to Einstein's equation h nu minus work function. Work function is the minimum energy required to liberate the electron from metal surface, and it is h nu minus h nu naught, it is k. Comparing with the straight line equation, standard straight line equation, if we compare, k can be compared with y. Planck constant, actually the slope of the graph, tan theta is equal to h, and work function can be compared with c, that is the negative intercept on the y-axis, and frequency, it is actually threshold frequency, minimum frequency required for photoelectrons, threshold frequency. Negative intercept on the y-axis is equal to, it is in between -1 -2, so therefore it is 1.5 eV, because this energy given in eV actually as per the option. So the work function of the material is, directly by comparing with the standard equation of straight line, it is answer is 1.5. And another one point I must say here, this is actually threshold frequency. So next problem. Thick surface is illuminated by light with wavelength lambda. Stopping potential V is equal to AC by lambda minus work function, and the second equation, it is stopping potential V by 3, it is AC by 2 lambda minus work function. We can say V is equal to 3 AC by 2 lambda minus 3 work function. Comparing these two equations, we can write AC by lambda minus work function equal to 3 AC by 2 lambda minus 3 work function. So 2 work function is equal to half AC by lambda. Work function becomes 1 by 4 AC by lambda, and it is h nu equal to 1 by AC by lambda. Nu naught is the threshold frequency, or the maximum wavelength corresponds to the threshold frequency, that is minimum frequency of the incident light, and it is AC by lambda naught equal to 1 by 4 AC by lambda, and lambda naught, that is maximum wavelength is 4 lambda. Threshold wavelength for the metallic surface is, correct option is 2. Next problem. Potential difference across the collector of a transistor used in common emitter mode is 1.5 volt. So ICRC equal to, actually it is VCE, it is given 1.5 volt in the problem, and you know IC and the resistance in the problem given is 3 into 10 to the power 3 1.5, and from this we can say collector current is equal to 0.5 into 10 to the power minus 3 ampere, and this is 0.5 milliampere. And you know current amplification factor in CE mode of connection beta equal to IC by IB, and from this result IB equal to IC by beta, and here it is 0.5 milliampere by 50 beta given in the problem, so it is 0.01 milliampere. Okay, and you know from KCL in transistor mode of C mode of connection, emitter provides majority carriers, charge carriers to the collector through base. So therefore we can say emitter current is equal to base current plus collector current, and it is already calculated 0.5, and finally the result is 0.51 milliampere. Right option here is 2. Hope you are understanding what I am discussing here. Next problem, let us see the shortest wavelength X-ray emitted from X-ray tube. Already I discussed, you know, lambda cutoff in the previous problem. It has been discussed, it is in volt, V in volt, and this is nanometer. Okay, and V is the potential difference of the applied across the Coolidge tube. So lambda inversely proportional to the voltage applied across the Coolidge tube. You just go through the option. The current in the tube is not the right option. The voltage applied to the tube, this is the right option here. Next problem. In the following common emitter circuit, beta 100 and VCE 7 volt. In the biasing voltage in the output circuit of transistor given actually 15 volt, and this 15 volt drop at the external resistance RC, and current through this is IC, and biasing voltage required for CE junction, it is VCE, and 15 and RC in the problem it is 2 into 10 to the power 3 kilo ohm into IC, and VC is equal to 7. And from this calculation we can say this is 4 milliampere. You just pause the video and calculate this simple equation, mathematical equation. IC is equal to 4 milliampere. but we know beta equal to IC by IB. IB equal to IC by 100, and it is 4 milliampere by 100. It means 0.04 milliampere. Question. IB is the question. Okay, finish. Option 2. Next. Here A connected to minus 10 volt and point B connected to 0 volt, diode D2 and diode D1. This is PN D2 diode. It is forward bias. P connected to higher potential and N connected to lower potential. You know, when any diode P junction is connected to higher potential and N connected to lower potential, the diode we can say is in forward bias. So majority carriers are responsible to conduct the electricity through the diode, whereas D1 in reverse bias. Because P end it is connected to lower potential and N is connected to higher potential. Since D2 is in forward condition, so potential at the N1 end, that is N junction of the diode 1, it is connected to higher potential and P junction is connected to lower potential. So D1 is reverse bias, whereas D2 is the forward bias. You just go through the statement here: D1 forward bias, D2 reverse bias, but hence current flow follows from A to B. It is not the right option. D2 is forward bias, D1 is reverse bias, and hence no current follows from B to A. It is, and vice versa. So this is right option here. Next problem. Work function for aluminum surface is 4.2 eV, the cutoff wavelength for photoelectric effect. Simple problem, direct questions. Work function is equal to AC by lambda max. This lambda max equal to AC by work function, and it is 12,400 by work function in EV. You have to put the value of work function in EV, electron volt, and wavelength is strong. So therefore, simple calculation, it is 12,400 by 4.2. So without calculation, we can say the 12,400 upon 4.2. It means the value should be greater than 2, but slightly less than 3. So right option here is 1. Simple. Next problem. Formation of covalent bond according to wave mechanics. Of particle the atomic orbit which are involved in formation of covalent bond can be expressed as wave function. So covalent bond actually sharing of two electrons of nearby two atoms. It is actually to fulfill the octet or doublet. The electrons in shares between electron shares of two atoms, and they form a covalent bonds by the help of the wave nature of particles. So here right option, wave nature of electron. Next problem, the difference in the variation of resistance with temperature in a metal or semiconductor is essentially due to difference in the actually in conductor resistance equal to R naught 1 plus alpha T. So with the rise of temperature, resistance of conductor increases because of the thermal velocity of electron, energy getting from outside agent, external agent, and resistance, conductivity of conductor decreases, decreases, and henceforth resistance increases. But in the case of semiconductor behaves as it is valence band and it is conduction band, and this is forbidden band. You know, in the band structure theory, semiconductor behaves, SC behaves as an insulator at 0K. That means conduction band completely vacant. There is no conduction electron available in the conduction band at 0 Kelvin. But with the rise of temperature, electron excited and gets energy, heat energy, and it can gets energized and can overcome the forbidden gap and move to the conduction band. And in the valence band, electron left a charge carrier, immovable charge carrier, that is hole. And with the rise of temperature, the number density of conduction electron goes on increases. So therefore conductivity increases with rise of temperature, and resistance decreases. Resistance of semiconductor decreases. So this is the basic difference between conductor and semiconductors. Therefore we can say variation of number of charge carrier with temperature. This is the basic difference between conductor and a semiconductor. Next problem. threshold frequency for metallic surface corresponds to an energy 6.2 eV. You know, kinetic energy of incident wave equal to half mv max square plus work function, which I have already told earlier. So kinetic energy, it is related to stopping potential, and stopping potential in this problem, it is given 5 eV, and work function corresponds to, threshold frequency corresponds to an energy, that is work function 6.2 eV. So total energy of incident wave is 11.2 eV. And in this way, lambda is equal to 12,400 by E in EV. I mean 12,400 by 11.2, and it is approximately 1100 Armstrong. X-ray region, it is less than 100 Armstrong. Visible region, you know, 4,000 Armstrong to 8,000 Armstrong, and it is greater than 8,000 Armstrong. So therefore, I think the correct option is 1. It is ultraviolet region. So ultraviolet ray is incident on the metallic surface, which for this the stopping potential of the radiation incidence is 5 volt. So in this way, we have discussed 1 to 45 questions. We hope that you are all understood what I have discussed today, and it will help you to enhance your performance. That's all.